Hello everyone, I'm sorry I'm a little bit late. I have some trouble with my software, and one more time sorry, because I was too nervous, and I was afraid that I'm already can't be started the stream. Today I will start that. My name is Andrei Muhamed, and I am a relay protection and control engineer in NPC Ukrenergo Ukraine, but also I one of the developer of the Relay Helper app, and today we will look at one of the case study. It's related to the 330 kilovolt CT explosion. It's an interesting case, especially for me, because in this case only electromechanical relays was at substation, and all protection was worked correctly, but there was interesting how breaker failure protection acted. So we had last summer we had few such cases with CTs, and it was when the weather was very hot, but these cases happened not in the day, but in early morning and or in late night. All CTs was oil CTs, and was built in they were pretty much old, and were built in Ukraine in late 70s, in the beginning of the 80s. So before war we had the program for replacing them with new cities, but unfortunately the replace was done in a little bit a different way. So we will start with quick review of primary scheme and quick review of protection philosophy, because to discuss sequence of event we need to understand how it should work. So this city was exploded, so I place the short socket was here. We have on that line we have two breakers per line, two buses, 330 kilovolt buses to substation connected for 330 kilovolt lines, two auto transformers, and around 110 kilovolt lines. As I said, all protections are electromechanical, except digital fault recorder. Each protection connected to the two CTs and see the sum of the currents of each circuit breaker. Also, we have line VT. Here on that core connected bus bar protection of this bus, and here bus bar protection of that bus. We have as main protection we have phase differential protections, protection, and also backup protection with distance, earthfault, and overcurrent, instantaneous and overcurrent. Also on that line implemented two communication channels, one for phase differential protection and one for teleprotection scheme. We use a scheme like a POTT scheme, but it's a little bit different than usual Western POTT scheme. Through this second communication channel, we not only send protection commands, but also system integrity schemes commands. Protection commands only three. The first signal is direct transfer trip with R exhibition and inhibition, and second command is direct transfer trip but with controls and fast R, and third command is using for teleprotection scheme. Quickly a few words about phase differential protection. If you don't know what it is, the main principle that during short circuit on the protected object there will be pauses in high frequency signal, and protection will trip. In external short circuit there be a consistent high frequency signal. So if you have any questions, please type in the chat. I will try to answer them. We have two records from substation A side, but also from substation B side. I can't say exactly where, in which core the short circuit was, but I believe it short circuit was somewhere near spare core. And when I'll show you a record, I describe why I'm thinking so. So let's start with a record from substation A side. Okay, so at the top we have voltages a little bit below currents, and the last analog channel is high frequency channel of the phase differential protection. Here we have digital channels. There are a lot. Unfortunately, I don't have much time to translate all the signals, but I'll describe it during this case study. So as we can see, we have phase A to ground short circuit and very strange current waveform. Also there are zero sequence voltage, and we can calculate zero sequence current. At this point the value from phase A current is around 2.7 kiloamperes, but let's return here. So when the short circuit started, we have current flow from that side. No, not this arrow. Okay. From this bus, also from second bus bar, and from the opposite side of the line. Okay, but let's build a vector diagram. I made phase A voltage as base channel, and it's not zero. If you, we can see that it's around 11 kilovolt, and as we can see, the current, the power is not directed into the line. It directed to the bus bars. It's because a digital fault recorder connected to this first course, and by this vector diagram we can for sure say that the short circuit was not in that core, in some another core. But also we have to understand that we can see not only one city, we see some of the two cities. So because of that, current is not so big, because we see the difference in these two currents, like that. So the last analog channel is, as I already said, is high frequency phase differential protections signal it in during external short circuit. It should be like that. But here we can see some pauses, and at that point phase differential protection already tripped. But first, at this point, trip was from bus bar protection. Let's see. Okay, this signal shows that first CB was opened by bus bar protection, and from that point we can see only currents, these two currents. And at this point, because of the for the all line protections, the fault was behind the zone, so the distance protection is not worked, directional ground protections didn't work, and also phase differential protection worked a little bit early, and I'll try to describe while it works. So because of overcurrent instantaneous step without direction, it tripped, and it tripped with R start. So Let's at this point CB1 was already opened, and line protections tripped this second circuit breaker. And as I said, we have communication channels, and these instantaneous overcurrent protections initiate the second signal to be sent on the opposite end. It means a trip with IR start. So let's look at the protection at the substation B side, and we can see that short circuit on phase A, and here we can see the value from of this phase current is around 2.3 kiloamperes, and it's here it's almost near that value, because of that not some because currents from these two current transformers eliminates each other, and we can see only this current that flows from opposite substation. Sorry. So we can see what protections are tripped, and here we can see this. This is the signal from the opposite end to trip, and also a little bit up trip from phase differential protection. Why this happened with phase differential protection? Because I can say exactly on which core short circuit was, but in the beginning we see the normal for phase differential protection signal without pauses, and what interesting was in that case that short circuit was on the phase that used for high frequency filter. So on phase A we have high frequency filters with line trap, and I believe that because of the damage of the CT, we received this pause, and phase differential protection worked on both ends. But at first point worked instantaneous overcurrent instantaneous step, and tripped the line and sent signal to the opposite end. So and here this is the time of the second circuit breaker, tripping time. So it's about 75 milliseconds. Let's see what was next. So because here this pause is we have fast R implemented on this substation. The pause is around 300 milliseconds, and we can see that this pause a little bit more, because this time includes time of the closing time of the circuit breaker. So here we can see the R from the substation A side, and these are only of that circuit breaker, because busbar protection trips with R inhibition on that circuit breaker, and because okay, at this point we have the circuit breaker opened. So we talking about this moment, and it happened because line protection tripped with R. So this circuit breaker switched on fault, but as we can see, we have a very strange waveform of phase A current, and this strange waveform because we also in that case see the difference between these two cores, and it's pretty they're pretty much the same, so this is like only difference of them, and okay, so this is contacts of the auxiliary contacts of that second circuit breaker. And here we can see that here circuit breaker was opened, and here it closed. But what happened next? For line protections, this short circuit is behind the zone. For this busbar protection, it also behind the zone, but in that case, this busbar protection worked, and it also started the breaker failure protection of the line. So this time of the voltage that appeared online, this is the time of the breaker failure protection and tripping time of that second circuit breaker. So one more time, in this case, because for line protections and it was behind zone, this busbar protection worked and started breaker failure protection, and this breaker failure protection tripped this circuit breaker, and usually breaker failure protections send one of the protection commands on the opposite end, direct transfer trip with R inhibition. But this command not help, because here we can see the R from the opposite end, and it's a little bit strange why it happened, and I only can say also that maybe it was because this high frequency communication channel also uses phase A to communication with substation A and substation B. But let's see the records from the substation B side. So here we also can see that short circuit was cleared at this point. Here we can see that voltage line is energized from the opposite end, and after that we can see the R from substation B side, and this signal, like 11 signal, this is it shows that substation B side received this signal to R inhibit a little bit not in time, and at this point our scheme started to work, and here this circuit breaker was closed on short circuit. So for me this case interesting because we can see very unusual work of the breaker failure protection, and I saw this type of work sometimes when when short circuit happened between circuit breaker and CT, or in the core of CT. And I understand that we while we are analyzing or taking part in designing in design of the protection system, we also should consider such cases and should understand how protection will act and how breaker failure protection can help us to clear the fault. So I was involved in investigation of the protection behavior. I really don't know a lot of details about where was it found exactly where was short circuit, and I believe in thumbnail we can see that such events happened with explosion, and usually a fire on substation, and maybe this CT was damaged so that no one can investigate where exactly was short circuit was. So let me check if I have questions from you. Okay. You have some time to ask me, and I want. This case was not very big, not very complex like last cases. The last case about 750 kilowatt line was very complex to me, and I prepared a lot, and I decided to make not so complex, and make stream a little bit shorter. So I want to announce the next stream. It will be about cases when protection system like started to be crazy, or sorry, I don't know how to correctly say it in English. So I in my collection of events I have some cases when IDs acted strange, like them get really silly. They see some analog values that not present in the system, or just straight acted strange. Anyway, thank you very much for watching my not very good English. I hope that you enjoy this video, and thank you. See you next time. Bye bye.